For decades, Europe's reputation as a temperate summer destination made it a sanctuary for global travelers. Tourists from tropical regions would specifically visit during the summer months to escape the intense heat of their home countries. The summer of 2026 broke that long-standing pattern. In June, the United Kingdom recorded an average temperature of 36.1 degrees Celsius. It was the highest temperature ever recorded in June for the UK, signaling a shift in the seasonal calendar. Across the Channel, the numbers were even higher. Temperatures in France climbed between 39 and 43 degrees Celsius, with 147 different cities breaking their historical records for the highest heat ever recorded. While the intensity of the heat is significant, the timing is what proves a systemic change is underway. Historically, European heat waves peaked in late July or August. These records occurring in June indicate that the climate is now operating outside of its traditional seasonal windows. It is a mistake to assume all heat waves are the same. In Australia, for example, the heat is typically dry. In Europe, however, the rising temperatures are arriving alongside a significant increase in atmospheric moisture. Human bodies cool themselves through the evaporation of sweat, but when the air is already saturated with moisture, that evaporation stops. The heat stays trapped inside the body instead of radiating into the environment. The danger persists after sunset. Nighttime temperatures are remaining between 21 and 30 degrees Celsius, which eliminates the critical recovery window the body needs to shed the thermal stress accumulated during the day. When high humidity and hot nights occur together, the body's natural thermoregulation fails. This transforms a simple weather event into a direct biological threat to the most vulnerable populations. To manage this heat, European cities depend on massive cooling systems powered by the electrical grid. Much of this clean energy comes from nuclear power, which provides a steady baseload that intermittent sources like wind and solar cannot yet match. These nuclear reactors rely on a constant supply of cool water from nearby rivers to regulate the temperature of their cores and prevent them from overheating. The current heat wave has warmed these rivers to the point where the water can no longer effectively absorb heat from the reactors. The water is physically too warm to perform its cooling function. As a result, power plants are forced to drop their output or shut down entirely. This happens precisely when the demand for air conditioning is at highest, creating an energy deficit during the hours of peak need. Because the grid lacks enough battery storage or consistent alternatives to replace this lost nuclear capacity, the energy infrastructure becomes paralyzed by the very climate conditions it was designed to help us endure. The data shows a clear acceleration in extreme weather. In the 1990s, Europe experienced 5 severe heat waves, averaging one every 2 years. Between 2000 and 2025, that frequency spiked, with 20 distinct heat waves recorded in a similar timeframe. This surge in frequency is the direct result of human-induced climate change, which has made these events 10 times more likely to occur than they were just 30 years ago. We are no longer observing 50-year natural cycles. Human activity has shortened the window between these events, turning what used to be rare occurrences into a crisis that arrives nearly every 5 years. This shift extends far beyond Europe. Global sea surface temperatures are rising steadily, creating the thermal energy necessary to increase the frequency and strength of tropical cyclones. In South Asia, the pressure is equally intense. India and Pakistan recently recorded their highest April temperatures on record, as the regional climate patterns shift toward more extreme heat. Looking ahead, the Australian Bureau of Meteorology has confirmed the arrival of a super El Niño pattern, which typically drives global temperatures significantly higher. Based on these ocean warming patterns, 2026 is likely just a precursor. The current data suggests that 2027 will bring even more severe global heat waves and prolonged droughts. The 2026 heatwave arrived as the calculated result of a warming planet, establishing a new global baseline. This shift represents a permanent change in our environment that will require a total systemic overhaul to survive.